simply, okay, these are formulas that you will have on your little flashcard, okay? K equilibrium is, is H3O plus OH minus. Okay, it's H3O plus OH minus. So this is a formula, and remember what square brackets mean? What do they mean? Molarity, always. Square brackets mean molarity. So, for water, it is going to be H3O plus times OH minus. Okay, this is a formula you're going to need to do the math. Okay, so this is the first formula on your flashcard. K of water is the concentration of the hydronium, and at pH 7, okay, at pH 7, H3O plus will be equal to OH minus at pH 7. Okay. Exactly. So look at this, okay? If Kw is equal to 10 to the negative 7 times 10 to the negative 7, because if pH is 7, the H plus is simply 10 to the negative 7, right? That's what, if pH is 7, the H plus, I'll show you how to do that in a minute. But think about this. So at pH 7, what would Kw be? No, yeah, it will be 10 to the negative 7 times 10 to the negative 7, which is 10 to the negative 14. And that's what this number is. Do you see how they got it? Okay? So that's what we're going to assume the Kw is. 10 to the negative 14. It's a constant. We will always know this number. Okay? So that's the first one you need to keep. Now for pH. This is how we calculate pH, and I hope Steve has done this. So if your pH is 6, let's say, pH is 6, and you have negative log of H3O plus, how do you calculate the concentration of H3O plus? The trick is, you take the negative sign to the other side, so you take negative 6, and you take 10 to the power of negative 6. That is what H3O plus is going to equal. Please don't divide both sides by log. It doesn't work like that. Did everybody follow? So the way we solve for H3O plus is take 10 to the power of negative 6. Now that you must be able to solve. It's easy. If it's just 10 to the negative 6, that's the answer. You don't even need a calculator if you have whole numbers, right? But what if I said 6.3? Yes, 10 to the negative 6 exponent. But what if I said pH was 6.3? Now, saying 10 to the negative 6.3 doesn't really sound right. Now you got to solve it. So in your calculators, enter 10 to the power of negative 6.3, and what answer do you get? I just made it up, right? 6.3 pH. So they say, I just made that number up, yeah, 6. Yeah, pH can be, pH doesn't have to always be a whole number, okay? It can be 5.4, 4.9, it can be numbers like that. Or 4.23. Yeah. Yes. Did everybody get the answer Emmanuel got? 5.0 times 10. Do you see? That's the answer I expect on the test, and that is what will be in your multiple choices, okay? So don't just leave the answer as 10 to the negative 6.3. There's no such thing, okay? Did everybody get that, please? And the unit for square brackets is what? Molarity. Did everybody get the square bracket is molarity? So finish off the answer with the right unit. Yes, we're going to look at the problems. Yeah. We're going to look at different kinds of problems. The other other question that I could ask you is, what if I give you the OH minus concentration? Okay, let's see. Let's do this problem. What if I say the OH minus concentration in a solution is 2.3 times 10 to the negative 2 molar? Always, square bracket. What is the pH? What is the pH of this solution? Now, on the test, this is what I see students. Oh, yeah, I know how to do this. pH is negative log of hydrogen ions, right? Negative log of H plus or H3O plus, and by mistake, they just plug this number in. Are these two the same things? No. And this is what I typically see on the test. Can't do that. So what you need is the H3O plus, right? All you have is the OH. Now, wasn't there a formula I just gave you for K of water? What was the formula for K of water? Exactly. H3O plus times OH minus, we said was what? Always equal to what? No, was what? Yeah. 10 to the negative 14. Right? Now that's the formula you're going to use. Didn't I just give you the OH minus in the problem? So you're going to solve for H3O plus first. You see that? So now do it. By the way, 10 to the negative 14 is 1 times 10 to the negative. Same thing, okay. All right. So now plug in the OH minus and tell me what should your H3O plus come out to be. Solve. Going to divide both sides by the OH minus. So you're going to divide this side by the OH minus, which was what in the previous problem? Do you remember? 2.3 times 10 to the negative 2, correct? So you're going to divide this by 2.3 times 10 to the negative 2. Now does it make sense to you how we're doing this problem? Good. You divide? Yes, because you have to divide both sides by OH minus, right? Yes, yes ma'am. Yes, ma'am. That's it, molarity. Okay. Now, careful. It's negative 2 at the bottom, right? So now when you take it up, it's negative of negative 2, isn't it? What do you do when you divide? Subtract. Subtract. So you have 10 to the negative 14, negative minus 2, isn't it? So it will be negative 14 plus 2. Yes. Is everybody following what I just did? Okay, when you're multiplying, you add exponents. When you're dividing, you subtract. Okay, now don't forget you still have to do 1 divided by 2.3. What's that? So 0.434 times 10 to the negative 12. Is that what you all got? I don't like this 0.434. Huh? Okay, wait. Okay, let's do it. It's the same thing. Okay, your calculator should give you now. By the way, this could be a question on the test. Report this in the correct form of scientific notation. It shouldn't be 0.434. Where should the decimal be? After 4. Which your calculators do for you, right? So it'll be 4.34, and I get asked, now what do I do with this? If I'm losing negative 13. Okay, see how much time it took us to just figure out the H3O plus? So you do all of this. Don't forget what this is. This is H3O plus. Now can you do the pH? Yes. Now what you're going to do is say pH is equal to negative log of this whole big thing number, 4.34. Is everybody following with me, please? Times 10 to the negative 13. Okay. Now, this step you need to do in your calculator, okay? Take the negative sign inside, please, or you can just leave the negative sign. Just actually forget about it. Let it be there. Just do log of 4.34 times 10 to the negative 13. It should come out to be a negative number. No. Just do log of 4.34 times 10 to the negative 13. And what did you get, Maria? There you go. I said you'd get a negative number, and you did, right? The pH can never be negative. So don't forget you have a negative sign, and you get negative 12. So what does that make the final answer? Positive 12. Got it? Got it? Very good. No, Nina Marie, you didn't get it? What did you get, ma'am?
I got 6.37 times.
On that problem, ma'am, that we were just doing? Okay, do it for me one more time, please. You should have, so did you do 1 times 10 to the negative 14 and divided it? But did you put...
I got the right answer.
Oh, you got the right answer. Oh, then try the log again. Please, I'm sure you're pressing the wrong number. Yeah, the ln or log. By the way, what did Michael, did you have to press ln or log? Log. Okay. You did log? Really? Log of 4, it should be,
I got it.
okay. So on the test, be careful about which number you're pressing and which button you're pressing, okay? Be careful, because it's all the wrong answers will be on the choices.
So the 12 is the right.
The 12 is the correct answer.
So we have the molarity, or what is it?
I could ask you for anything. I could ask you for the pH, like this problem.
And the 4.4 is the molarity
Of H3O. Yes, that's what I wrote here, see? Yes? Okay. Okay, good. I told him that I need you to do this because I'm going to hit it. I think that's what he's trying to help me. Okay, so the pH, now here's a little trick I'm going to teach you for the test, because test time is very important, right? So you might be asked to find the H3O plus. That's a straightforward, simple question, easy one. I might ask you for the OH minus. That could be a two-step problem. But I'm going to teach you a little trick. The pH, okay, so here are the two formulas you're definitely going to have on your little flashcard, yes? But there's another formula that you could also use. pH plus POH is always equal to 14. pH plus POH is always equal to 14. Okay? Plus POH. So let me show you what I mean.
So if you find the OH, then you can subtract that from the
Exactly. Yes, because if pH is negative log of H3O plus, guess what POH is? What is POH? Negative log of what? Of OH. Do you see what I mean? The formula was pH. The formula I gave you is pH plus POH is always equal to 14. Okay? So this is what I'm about to tell you. Let's say on the test I give you the OH minus, and I ask you to find the pH. What you can do is use this to find what?
OH. No, POH.
POH. And then use this to find pH. So much easier. You all see what I mean?
Yeah, negative log.
Yeah. Well, for the POH, you still have to do negative log. You still have to do negative log, right? But I think it's a little simpler to do it this way. But all answers lead to the same. I mean, all routes lead to the same answer. Did you all get this, please, folks? Okay, so now let's do some problems, okay? Here's the first question. What is the pH of a 1 times 10 to the negative 4 molar HCl? HCl solution. So when they give you HCl, the hope is you already memorized your strong acid list. You will know that HCl is an acid. Thank you. Then that means what is the problem actually giving you? Even though they don't call it H3O+, that's what you're having in this one, because acids can release H+, right? So notice, folks, in this question, it does not tell you the H3O+ concentration. You need to know that when you're given a strong acid, that number, 1 times 10 to the negative 4, stands for the H3O+ concentration. You need to know that. So what I'm saying is you need to connect these two dots on the test. Yes? So once you're given the H3O+ concentration, can you find the pH? Do the same thing, negative log of 1 times 10 to the negative 4. I feel like a spy. I'm going to draw on the look. With my flash drives in it. You know the spies, right? They always exchange envelopes in parks and places like. Okay, once again, let's address it. Whenever, okay, this is why I said if the the base. So when the problem says HCl, when the problem says strong acid, okay, when the problem has the word strong acid in it, or the problem says a solution of H2SO4, or the problem says a solution of HNO3, do you remember me saying you need to memorize your list of strong acids? Unless you know your acids, none of these problems are going to make any sense. When the problem has these words in it, it is actually giving you the concentration of what? H3O+.
H3O is the acid.
Yes.
And the base is the OH.
Correct.
So because of the solution.
No. It'll always say a solution. But now if it was saying the base, it'll give you what? The base is NaOH. Well, it has OH in it, doesn't it? Doesn't NaOH have OH in it? That's the key. So what solution, what am I giving you in this problem? If I tell you the concentration of NaOH is 2.0 times 10 to the negative 2, then you should know that you have what? Not the H3O+, you have the OH minus. You all get it now? Good. So now let's go back to the problem. In this problem, read it. It says, what is the pH of a 1.0 times 10 to the negative 4 molar HCl solution? The assumption is you already know what HCl is. If you don't know that, this problem will not work. Oh.
HCl is strong acid.
It's on that list, remember? Okay, now, so that's why this was given to you. Plug it in. What did you get? Did you get 4?
Yes.
Excellent. So let's move on to the next problem. Okay, now for the next. Look at this problem. Here it's more direct. What is the H3O+ of a solution which has a pH of 6? By the way, they've done it all wrong. They've used 4. They should have been 6. By the way, yeah, they should have been 6. They should have been 6. So mistakes. Yeah, maybe. So why don't you try this problem, please? Whenever the pH is given, what do you have to do to find H3O+? How do you get rid of log? Well, in this problem, it's straightforward, if you ask me. What you would do is say pH is 6, right? So then what is the H3O+ constant? Remember how I told you to get rid of log? What do you have to do? Remember me telling you that? Yes. Right? Do you remember me telling you how to get rid of log? Is do 10 to the negative 6. That 6 is the pH, right? And what did you get? 1 times 10 to the negative 6 is your answer, right? When the pH is a whole number, you don't even need a calculator to find H2 plus. Okay, got it? So that's another kind of a problem. Now look at this problem. Don't look at how it's done. What is the pH of this solution? I'm sorry, ma'am? Once again? The answer for which problem? Previous problem? This one? The answer is just 1 times 10 to the negative 6 molar. Okay, how are y'all going to do this problem? Are you confused on this one?
We use the pOH formula and then use the
Right.
pH plus pOH.
Exactly. Now look at this problem. It says KOH, right? So what concentration, whose concentration do you have? Exactly. The 1 times 10 to the negative 3 molar is the concentration of OH minus. Did you all get that from the problem? Okay, so I have the OH minus. How do you find the pH? Well, one way to do it is to find the pOH first. Do you remember me telling you how to find the pOH? Yes. Is negative log of the OH minus, correct? So, negative log of 1 times 10 to the negative 3. Is everybody with me or no? Have I lost you? Do you all follow? pH and pOH are the same things, folks. Except in pOH, it's negative log of OH. Right? Now remember, Brianna, here in this problem, it is a very complex, it's not one step. They're not giving you the H3O plus. So you have to first find the pOH. Otherwise, you cannot solve this problem. On the test, students use this number directly to find pH. Wrong.
Oh, so it's the pOH minus.
Yes, exactly. Okay, so what does the pOH come out to be, Josh?
3.
Oh, it's 3,
Yeah,
yeah.
pOH is 3. Yes? All right, then what I said you could do is say pH plus pOH. Remember the formula I gave you? Is always 14. If pOH is 3, what's pH?
How is that possible?
Yeah, that's what. It's mathematical, that's why. It's always equal 14. So what, if pH is 3 and the total is 14, what's pH? Did you all get it? Good. Yeah, these problems are fun. Okay, pOH is over here. Yes, it's the same as pH. Correct. Okay, now here's another problem. I'm going to throw a bunch of problems because these are so easy that I hate to see you miss it on the test. Okay, now don't look at how they've done it. Okay, so I'm going to take this out. Oh, I don't know if I can. All right. Okay, what is the pH of this solution? Now again, if you don't know what HNO3 is, you're not going to be able to do it.
So pOH and pH is the same formula. Except one's acid and one's base.
No, pH and pOH cannot be the same formula. pOH is negative log of OH minus. Yes? And pH is negative log of H3O plus. So they're not the same things. They're similar. Did everybody get this, please? Maria, did you get it, ma'am? Excellent. Now in this, you're given that, what is the pH? Now just tell me how you're going to do it. Don't look at how they're doing it. Okay, what is given to you? I think that's the biggest problem we're having here, is figuring out what's given. Yes, nitric, this is what? HNO3. Do y'all know what it is? It's and if you don't know that list, you're not going to like these problems. You see what I mean? Good. So that means this is the concentration of the base or the acid? Good. Now that you have the H3O plus, can you find the pH? This is a one-step problem, right?
Those are the easy ones.
Yep, these are the easy ones. You're right.
I like these ones better.
I know. I know.
know, right? Oh, it's tempting.
Okay, what is the pH of a 2.5 times 10 to the negative 4 molar HNO3 solution? What is it? Excellent. 3 points, that's it. And remember, pH has no units. Right? pH is unitless. Got it? All right. Just when you think you got it, what about this problem? Don't look at how they done it.
Would you keep that as a... Do they have a 0.60?
0.
That's it.
Okay, I want everybody to write this problem down. What is the OH minus of a solution with pH of 4.95? Okay, did you write it down? No. What? I'm going to write it there because I think everybody's just copying what is up there. No, I'm just kidding. What is the OH minus? Okay, there you go. What is the OH? Even I can't remember. Oh my God. What is the OH minus when the pH is 4.95? Question mark. I'm not writing all the words in between, okay? Question is, what is OH minus concentration when the pH is 4.95? Do it. Because I don't want you to look at how they did it. So what if this was a test right now? Yes, 3.60, correct. Yeah, I want you to try this out. Do this all by yourself. And see if you know how to do it. What if this was a test? And this was worth 50 points. So your life depends on it, okay? All right, folks, what's the deal? How do I do this problem? Can you guide me? Okay, wait. Listen. Okay, so the pH is given. I guess if the pH is given, I can definitely find H3O plus. Agreed?
Yeah.
Well, but that's not what I want. I want OH minus. So I guess what I could do is use the formula. Do you remember the formula I gave you? No, we don't need that one. We could use this formula. The one, Justin, what were you saying? H3O plus? Oh, you said the same. But you could use this one. H3O plus times OH is equal to 10 to the negative 14. Do you remember that? So you plug this in from the first page, right? Yes. You need to find H3O. So find H3O. So did you solve for H3O, Rebecca? You did it differently, but you could still get the same answer. You did it wrong, you think? Okay. So what was the H3O plus that you all got? I don't want the answer like that. You can't say 10 to the negative 4.95.
1 times 10?
You have to actually do it. You have to solve it, people. You can't say 10 to the negative 4.95. That doesn't sound right.
Oh.
Only if you have a whole number, you can say 10 to the negative 4. But you can't say 10 to the negative 4.95.
1.1 times 10.
Oh, yes. Yes, actually, you know what? That's true. That is true what she's saying. Okay, so this is what Brianna wanted to do. She said if pH plus POH, yeah, there's more than one way to do a problem. It's 14. That's what you all did?
Yeah.
Okay, I think that's fair. And you got 4.95 plus X is 14.
Yeah.
Good. And then what is X? There you go. 9 point what? Okay, why not? Of course. And then you take the 9.45 and you say 9.05 is equal to negative log of OH. Yes, we can do it this way too. Yes, and then you say 10 to the negative, oh my God, 9.05, which you have to solve though. Okay, what is that weird number, Brianna?
8.91250938.
Yeah, but I don't want all those. Just 8.9?
8.9.
That's it. Yes. Perfect. Actually, I'm sorry I discounted that answer. That's fair. But Josh, the way you were trying to do it is also just add Michael. Yeah, listen, all of us, that's the beauty of math, is there's no one way, there's no one correct way, there's more than one correct way. Did you do it, Rebecca? Is that how you did it? Then why did you say you were wrong? No. See? And this would be correct too. Okay, now on the test. Don't leave the answers like this, please. The multiple choices are not going to be like that. You got to solve it, okay? Plug it into your calculator and actually do it. Okay.
How will you do the other way? What other way you were saying?
The other way I was saying is what Michael and Josh were doing, which is find the H3O plus first with the pH. Okay, so for that we would say pH is equal to negative log of H3O plus, correct? Right? And the pH was 4.95, correct? So the H3O plus concentration will be 10 to the negative 4.95 would be equal to the H3O plus. You see? Solve and tell me what it is. 10 to the negative 4.95. Michael, what did you get? 1.12 times 10 to the negative 5 is what Michael got for solving that, and that is the H3O plus, correct? But I also gave you another formula. Do you remember that? The very first for water, H3O plus times OH minus is always equal to 10 to the negative 14. Remember that formula? So we divide both sides by H3O plus. Yes? So we divide that by 1.2 times 10 to the negative 5. And we divide this by 1.2 times 10 to the negative 5. Yes?
Yes.
Now you solve for this. This is 1 times, by the way. You solve for that, and what do you get? Same exact beautiful answer. That's it.
I love when they work multiple ways.
Yes. Yes, and both of you were correct. Both ways were perfectly right. Okay, and the answer comes out to be 8.9 times 10 to the negative 10, right? Did you all get the answer, please? Okay. All right, folks, the next thing we're going to talk about is neutralization reactions, because we're talking about an acid and a base. Neutralization means what? Acid plus base always gives you what two things? Salt and water. This is actually a double displacement. Look at it carefully, chapter 4. Okay? The H and the OH go together as water. The N and the Cl go together as sodium chloride. Do you see a double displacement here? Yeah. Now we can break this apart. So here's the thing. Whenever you have AQ, you can break things. So let's break things, okay? So if I say HCl aqueous, it will break into H plus and Cl minus. Very good. Okay? If I have NaOH, I'm going to flash the slide again, folks, just a second, okay? If I have NaOH, I can break it up to what? Na plus and what? OH minus. Here I see students breaking it up into O and H and all that. No, no, no. Ions, correct? So go back. So we're breaking apart into ions. Watch what happens. HCl breaks into what? H plus and Cl? NaOH into what? Na plus and OH minus? NaCl breaks into what? It still is aqueous. Na plus Cl, but water you cannot break. Water is covalent and it's not aqueous. See what it has? No liquids and solids can be broken. Liquids, okay, I'm going to say that. Liquids, solids, and gases cannot be broken. So you can only break aqueous. Does everybody get that, please? Liquid, solids, and gases cannot be broken. Okay, so now cancel everything that's common on both sides. Do you see the Na plus? Yes? Do you see the Cl? So, yeah, so the net ionic simply means the ions that did not cancel. What are they? H plus and OH minus. Giving you water. Yeah.
You have a question like that on the question of the left.
That one was precipitation reaction. Because remember we did that in chapter 4 too. So this is a lot of overlap with chapter 4. Okay. Now, we're going to look at how to calculate, and this, how many of us have done lab? Okay, so you've done titration, right? Excellent. So this is how we find out a concentration of an unknown acid when you have the concentration of the base given to you. Okay? So we're going to use a burette. This long stem thing is a burette. And we're going to use a flask. We're going to add the base dropwise. And we're going to wait for color change. When the color changes, we say that the reaction is complete. But what is the difference between equivalence point and end point? So let's go back. The equivalence point is when the moles of hydrochloric acid and NaOH are the same. Now look at this equation, right? Let me write it on a fresh page. HCl plus NaOH giving the NaCl. Can you balance this equation for me, please? NaCl plus water. What are the moles? What are the coefficients in this equation? Is this a balanced equation? Yes, it is a balanced equation, correct? So that means 1 mole of, so will I read it correctly when I say 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide to give me a mole of sodium chloride and water. Do you agree? Excellent. That means when the moles, so 1 and 1 simply means when the moles of acid are equal to the moles of base, it's neutral, right? That is the equivalence point. The equivalence point is the point at which the moles of the acid and the base are equal, okay? But the end point is not the same as the equivalence point. The end point is when you see color change. And to see color change, you have to have a drop of base in excess. Now you may argue that's only a drop. Yes, but still not the same. Yes, that's the one on which you saw the pink color, remember?
Yeah.
Right. So here are some indicators to change color. The neutral equivalence point is at what point? 7. But notice if you chose phenolphthalein as your indicator, what pH will it change color? Past the equivalence point, right? Look at its color change, 8 and 9. So if you got a fuchsia pink, what pH were you in, Brianna? Yes. And yes, the equivalence point says that you should be at 7, right? Okay, so here is the titration. This is how you do it. For those who have not done it in lab, you place the acid in the flask. That's the flask. She's taking it next semester, right? She said she'll go to the lab. But how many of you are taking lab? Only, yeah, Jordan, Alicia, Brianna, Maria, no? What about you, Dustin? Amy? Nina? Rebecca, no?
I like it.
Lab is fun. Lab's a lot of fun. We have a lot of fun. Okay, add an indicator and keep swirling the flask drop-wise. Keep swirling, 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 swirling until the color changes to very light pink. Look, how many of us got that light pink? Most people get a fuchsia pink, right?
Adding more when it changes more color.
It will get a little dark. That's it. Just a little dark. So, how do we calculate the concentration of our acid when we know the concentration of our base? Well, when it is an equal mole story, the formula can become, now for this you have to know chapter 6, but the formula can become MA times VA is equal to MB times VB. Very simple formula, where A stands for acid, B stands for base. So these problems, we're trying to find MA. So what do you have to do to find MA? Divide both sides by VA. Yes? Now in the problem, 3 things will be given to you. The molarity of the, M is the molarity, right? So the molarity of the base, volume of the base, volume of the acid will be given to you. You find MA. Does that make sense? Now, you can't assume that you're always finding MA. Remember, when there are 4 things you may be asked any for, and you're asked this, solve for it. So let's look at one problem. Okay, we finished that. Next problem. Determine the concentration of solution of hydrochloric acid. I think I went too far. Oh, I can't find the question. What happened? Okay, let's just do a different problem. Here. Calculate the, when you say square bracket NaOH, what is it? Molarity of the base. So that's, what are we trying to find? M? A or B? MB, right?
Yeah.
Base. Now see, on these problems, if you don't know what your base and acid is, you're not going to be able to do it. If 25 ml of this solution were required to neutralize 45 ml of 0.300 molar HCl. So what's that? Good. BB? What's that? Volume of the acid. And what's that? Okay, now can you try it? See if you get that answer. Use the formula M acid times V acid is equal to M base times V base. Okay, folks, so I see you. Now, in these problems, the best part is you don't need to convert your volume to liters. So long as you have milliliters on both sides, keep it like that. Don't complicate it. Did you all get this answer?
Yes.
Fantastic. Okay, before we move on, let's do another problem.
Did you want it 0.5 4 0 or you want it 4 6 8?
Because of the 4 6 weeks of the problem, I think.
So do we just put MB equals 0.54? We don't need to
Yes, you put the MCS and molarity. So on chapter 8, I'm going to take some practice questions in the book. Okay? So,
what was the answer for 0.54?
0.55. Okay, now, okay, here, page 275. Practice problem 8.8. Page 275. Problem 8.8. Yeah.
Now, A and B,
Just do A. Did you all get it?
Right.
Okay, folks. Did y'all get the answer, folks? What is the answer? 0.1? Is that what y'all got? Okay. Okay. So now, here you can practice the other problems at home, right? And then this is the last type of reaction. We're going to talk about buffers very briefly, folks. Oh yes. Buffer solutions are solutions in which there is pH change is very limited, right? Buffers do not let the pH of the solution change too much. That's why we call buffers. So they can absorb the hydrogen ions or the hydroxide ions in solution, and they can make the pH stay the same. We're going to talk more about buffers next class, but I want to talk about, because I don't have time to do all that. There are not very many slides on buffers on the, what do you call, canvas, but there are a few things in the book that I would like you to know, which I will talk about in class. Okay? Yes, next slide. But before we forget, I wanted to talk about the last type of reaction, which is oxidation reduction. Oxidation reduction reactions are those in which you have electron loss or electron gain. So when you lose an electron, what do you call it? Oxidation. Remember the acronym OIL-RIG. Oxidation is losing electrons. Reduction is gaining electrons. OIL-RIG. Okay? So if you look at this example, sodium, when the electron is on the product side, it means it's lost. Yes? When the electron is on the product side, it means it's lost. That is an example of oxidation. Exactly. So look at this definition. Loss of electrons, loss of hydrogens, gain of oxygen atoms, all of that is oxidation. But in this particular type of reaction that we're about to see, like this one, I don't see any oxygen added, do you? I don't see hydrogens, but I do see electrons lost or gained, right? In this case, lost. So we call this oxidation. Whereas in another example, you may see electrons reduction is the opposite. You gain electrons, you gain hydrogens, or you lose oxygen. Okay, once again, in this reaction, I don't see oxygens or hydrogens lost or gained, but I do see electron on the reactant side. That means it is gaining electrons. Does that make sense to you all, please? So that's an example of reduction. So follow the acronym OIL-RIG. Okay? On the test, remember that, OIL-RIG. Oxidation is losing, OIL. OIL is oxidation is losing, RIG is reduction is gaining. And of course, electrons is what we're talking about, right? Make sense? Okay, folks. So one other thing that I need you to pay attention to is the oxidizing agent. These are very tricky. All I want you to remember is the oxidizing agent itself undergoes the opposite. The oxidizing agent is the one that undergoes is reduced. The oxidizing agent is reduced The reducing agent is oxidized. Can you remember? So first things what you should do is figure out what's getting oxidized, what's getting reduced, and then decide the agents, okay? So let's take this example. In this example, and remember another thing, the agents are always on the reactant side, not the product. So between this reaction, Na plus Cl giving you Na plus Cl minus, the agents are on the reactant side. So the agent is sodium or chloride, okay? It's not these two on the other side. You get it? So now what you do is in this reaction, let's start a new page. If I say Na plus Cl gives NaCl, correct? The problem is you don't see the Na plus and the Cl minus, but you need to know that this is Na plus and that is Cl minus, right? The way you've written the formula, NaCl. So then you ask yourself, Na became Na plus. Did it lose or did it gain? Lose, right? So that means sodium is undergoing what? Oxidation. Cl became Cl minus. Did it undergo oxidation or reduction? Reduction. Now, the minute you have O over here, it underwent oxidation, it is the reducing agent. You get it? This underwent reduction, so it is the oxidizing agent. The opposite agent. The opposite agent. Get it? And remember, the agents are always on the reactant side, not on the product. Okay? Agents are the ones that cause something, so they have to be on the reactant side. Did you all get it, folks?
Wait, Na is the reactant.
No, wait. RA stands for reducing agent. I didn't write it out.
So Na is the reducing.
It underwent oxidation. Do you agree? So it is the opposite agent. It is the opposite agent. So Cl underwent reduction, so it is the opposite agent. It is the oxidizing agent. Yes. OA is, I abbreviated, I hope you understand. Cl is the oxidizing agent. I don't have room to write oxidizing agent over there because you know how this finger doesn't work very well and then you won't be able to read it. So I just abbreviated it. It's okay. Okay, folks, we'll stop there. Now here's the thing I want to tell you about next class, Monday. There is a chance that I may not be there on Monday. I'm trying my best to be there. If I don't, there will be a stop. And it's going to be David Casanova. Maybe if you know him? Okay, Casanova will come in to teach all about chapter 8, the buffers, the part that I was going to do. He will do it if I'm not here. And he's a great teacher. He's fun and he's really fun.
Casanova.
Yeah, right. So Casanova will teach, and then I will come back on Wednesday. I will go over the chapter and then start a little bit of mine, whatever I can do. So then for the test, you will have 7 and 8 for sure. It's almost on the 8, right? And then whatever I do on 9. And 9, remember, is a very short chapter. It's like the shortest of all chapters. So you need to make somewhere about 50 pounds over here. Okay, that's what I want to tell you, don't we? There is, the test is on November 30th, correct? Yes. Now, you can do the homework for 7 and 8 and bring it, and that's going to count as your extra credit. But in addition to the extra credit that I usually offer,